Thanks, Michael. This is work that I've been doing with Paul Gephardt. It came from something someone said ages ago about having high failure rates. In fact, we feel that we're often castigated for having high failure rates for maths. So what we did was we took looked at some data over 5 years on failure rates of subjects in the school, which is computer maths and data science, and just looked at what were the subjects with the highest failure rates, and we took a dozen of them. 10 were maths and stats, and 2 were computing. And we've just been looking at data, collecting data on these, and looking at whether we can basically predict the final mark. So
the camera, please.
Sweet. Oh, okay. Camera. Oh, it'll be much better if I'm not on camera, so don't worry about that. So the 2 computing subjects were first year programming unit and first systems analysis and design unit, but those haven't been included here. So what I'm going to talk about are 10 maths and stats subjects. But firstly, this data goes back a few years because it took a while to collect it, and there's also problems with the more recent data. But the university, we've got about 50,000 students, very large undergraduate university, Western Sydney. We're one of many universities based in Sydney. We have no prerequisites for entry, which New South Wales is good at not having prerequisites. I mean, the whole state of New South Wales, not the university. The state does not do very well, but we do particularly badly. We used to have prerequisites going back maybe 20, 25 years, but they were progressively removed. I remember one case where they said, you got prerequisites? And we all said, yes. You sure? Yes. Really? Yes. So they removed them. I don't know why they bothered to ask. But we have many, many mathematically underprepared students, really badly underprepared, with inappropriate studies at school or many, many years out of school, or both. So I looked for subjects with failure rates of about 30% and above, and came up with the 3 engineering maths subjects we teach. The first one is I've used the word remedial for it. I always have, even though people don't like the word. It used to be that the engineering maths 1 and 2 were standard maths, and the one I'm calling here 0 was put underneath it. These aren't the actual names, these are more descriptive names. There's a very basic mathematics subject, which is pre-calculus. There was an introductory differentiation subject, standard mathematics subject, a discrete maths, and 3 statistics subjects. The 3 statistics are all first statistics subjects, just slight differences because we tend to have different subjects for different cohorts of students rather than different levels, which some other universities have. Anyway, there's 10 subjects. So what we did is, okay, nothing went off.
Okay.
Okay. So we've collected data on these subjects, but for various reasons in the analysis we did, which were last year now, we could only use the data centrally collected by the university. And it's interesting to look at that because if senior management or managers at the university look at data on students, this is the data they have. They don't have my attendance records on tutorials. They don't have the data that those who run the subjects have on how students did in particular assessments, what their attendance was, or anything like that. That we have, but it's not centrally held and not available to the senior managers. This is the sort of data that's centrally held by the university. The subject grade and mark, the level of mathematics that they've done at high school. Now, some of this stuff, you think that this is good, solid data, but it isn't. Even with the school level of maths subjects at the school, the university doesn't always have that, even if students have studied at New South Wales, because if a student doesn't come in via UAC, they might not have that information. A little bit of it is apparently self-reported, and there's a lot of students who haven't done New South Wales HSC, and we have no data on their previous maths backgrounds. So you might think this is great data, and where we've got it, it's pretty good, but It's patchier, it's always patchier than you think. We've got their age, gender. All these analyses were done for male, female, because I think we only had one person who did not identify for gender, and we looked at that, we just removed that record. Fail non-submit, that's students who essentially drop out during the semester. What it means strictly is that they did not submit a mandatory assessment component, which is often just the final exam. So this is a very diverse group. More about that later. Whether they're domestic or international, their socioeconomic status, which I believe is based on postcode, language spoken at home, this is self-reported by students, first in family, and look at whether either parent has a qualification at certificate, diploma level or higher. That's self-reported as well by students. Then there's the ATAR, in New South Wales, the Australian tertiary admission rate, which we don't have that recorded for all students. Not all students have an ATAR, and not all students used an ATAR to get into university. True Rewards was a specific program where students could be offered a place at university before the HSC results came out. That's here just because there's a lot of those offers go out, huge number the last few years. College, that's where the students attended the university's foundation college before coming in to do their first year subject with us. Most universities have a foundation college. Ours is called WSU College. And even if we know that they've been to the college, we don't have the information of what they'd studied there. And then there's mode, whether they were full-time or part-time. Full-time is officially 3/4 load or greater. So that's the data we had, and that's the data we played with. So we've got data for about 5 years, but we could only analyse 2 years data at the time. After cleaning it, we had 5,421 records, which is enough to play with. You know, do some good playing there. And we were looking for important predictors for the final mark. So what we really want is predictors that matter, those that give information which we can use, which can be used where we can take some sort of action, or as I would like also to make some sort of selection via prerequisites, but that's not going to happen at my university for a while. Okay, so what we did was determine significant predictors for the final mark, determine the contribution of these predictors to the variation in the final mark, and construct a linear model for the final mark using the significant predictors. Now, the statistics were done by Volker. They took a lot of time on it, and we spent quite a bit of time discussing how to do this so we could really capture what we wanted. I think Volker did a very good job with it. Now, the final marks, one of the first things was shifting the final marks for each subject so that the mean final marks were the same, because they can vary very differently in some subjects. The standard deviations were all quite similar. The subjects are not all the same size and not all the same difficulty, so that was some sense lining them up. So there were 2 things done, 2 different analyses. One was the effectiveness of a predictor on its own, and then there was the loss of effectiveness left out. This was just sort of another check, and the two methods gave pretty much the same results. So significance level used throughout was 0.01. Now, because the FNS group, those who dropped out, are a very different group, and we had no information on them. It can be students who paid their money and were then never seen again, and we all know that some of those, students who never attend anything, never do anything. But there are students who have great attendance all the way up to the end and don't sit the final exam, and we don't know why. It might, for some students, it is a choice where they come to the end and they think, I have no chance of passing this subject. A sensible decision for me is to just dump that and concentrate on my other subjects. You know, it can be a sensible decision, or it can be, as I suspect often happens, is students just sort of, what, did I have a test last week or something along those lines? But we don't know. We don't have information about that. So we analysed all the data, including the students who had an FNS grade, but also did it again, excluding those. to see if it made much difference, because there are those, I think it's about 13% that we really didn't know anything about. So I'm presenting here the results that exclude those mysterious dropout students. So that's, yeah. So I've got two cohorts, which I've called the all cohort, which is all of them including dropouts, and the non-FNS cohorts, which are those who stuck it to the end, at least in some sense. Okay. Now, if a predictor explains very little of the variation in final mark, then really I'm not that interested. From the point of student success, attention, and all those things, it's not much use, even if it's highly significant. So here are the predictors that came up as significant with P equals 0.01. The ATAR and school maths level. Not surprising there. That's stuff we've probably all seen before, and I've certainly seen in every analysis I've done. And then the others are much less important, and explain much less of the variability of final mark. But there's the mode, whether full-time or part-time, whether they studied at WS College, the Foundation College, whether they're international or domestic, the language spoken at home. That's an interesting one, because we had about, I think, close to 10 different language groups based on an ABS grouping. But I think we don't have the data to say much about that. I think there's a story in there, but more on that later. Our special entry program, true rewards, socioeconomic status, whether the students were first in family to study at university, and their age. So these are the significant predictors. It's most of the ones we had. So most important ones, as you saw there, were the ATAR and HSC maths, the maths they'd studied at school. So the proportion in the final mark explained by a full model that's so using all the predictors, all the significant predictors, was 17.4%. So using all our predictors, 17.4%. But if you leave out all those except for the ATAR and school maths, you've still got 13% explained. So all those other predictors together don't really tell you much. They don't do much for you. It's the ATAR and the school maths. Okay, so that's just those two paragraphs. You might have noticed that gender was not significant at all. So that was, I thought, very interesting. It's great to see that, but only 30.8% of the students in these first two subjects was female. And that's really poor. That's really, really poor. And the highest proportion of females was 63.8%, and that was in basic mathematics, a pre-calculus subject, but it's largely for science students. And science at Western Sydney, like many other universities, is primarily biology and the life sciences. We don't really have physics anymore. I don't know if you can even do a physics major at my university anymore. So that subject, which is a very large subject, has actually skewed the data because of the sheer numbers in there. It's one of the two very large subjects in with that data there. It makes me worry that the 30.8% of students female, if you actually take out these science students, it actually looks much worse. I haven't done that, but I still think, however you look at it, 30.8% is shocking. The lowest proportion of females was in 8.9% in engineering maths 2. The engineering stream is 3 subjects, one after the other, each is a prerequisite for the following one. And when you get to the last one, you find the lowest proportion of females, 8.9%. I suspect that varies a lot from year to year because there is such a small number of females. You add or remove one female and the percentage will change quite a bit. There are very few, very few. So I think that's also rather depressing. And the proportion of female students decreases as one moves from the first to the third subject, even though in those subjects the females tend to do better than the males. So, depressing. ATAR, the tertiary admissions rank? Well, in Australia, more than half of all commencing students at universities have an ATAR greater than or equal to 80, and that sounds probably reasonable. The mean ATAR in New South Wales here is about 70, yet at Western Sydney, firstly, only 44.8% of the Dow data set had an ATAR recorded. So some of them might have had an ATAR, but it wasn't their university that didn't have an ATAR. So that's quite interesting in itself. And of those, the median and mean ATAR were around about 66. So you can see we're quite low. Across Australia, half of commencing students having an ATAR 80 or a bit more. For us, it's 66. So it's quite low. Now, the ATAR is an important predictor. The predicted increase in final mark at ATAR point is 0.47. So the ATAR is really quite important. That's what this data shows anyway. And across the 10 subjects, the mean ATAR ranged from 61.2 to 83.8. And the really disappointing thing is that the subject with 83.8, the mean of 83.8, is a very small subject and accounted for only 27 of those 4,500 records. So the next highest ATAR was 74.2. It's not particularly high. Now the school maths, which is really important. Overall, a higher level of school maths gives a higher predicted final mark. So there's 5 categories here. In New South Wales, all right, well, firstly, it could be that students do no maths for an exam at the HSC, or as happened for many of our students, we just don't know what they did. So this category at the bottom, it means there's none recorded, but we don't know whether for each student it means they did no maths at the HSC exam, or whether, I don't know, they studied in India and came here, whatever, we just don't know. It's a mixed group. Then there's elementary maths, intermediate maths, and in New South Wales we have extension 1 and extension 2. They're the 2 high-level subjects which correspond to the highest level in Victoria and across the rest of the country. I think, no, I'm not in maths methods or something, or specialists, that's right. Yes, extension 1 and extension 2. Sort of think of them as sort of on par with specialists is the way that they're usually categorised when you're looking nationally. Okay, but if you look at the coefficients in the full model, which predicts the final mark out of 100, the difference, the total increase in coefficients from the none unknown to the extension 2 is 22. And that's enormous. And it will be even bigger, because if we were able to remove all records for which and only keep the ones with no HSC maths, and remove those who are unknown for some sense because they did somewhere elsewhere and we couldn't categorise them, I suspect the difference would be bigger. But 22 is a very large number to me in this context. But then that aligns with some like the first many years ago. It showed that it was incredibly important. The level of HSC maths students do is very, very important. Now, so far I've talked about the 4,500 records across 10 different subjects over several years, with several deliveries in a year for many of the subjects. Now, we did analyses and look at a model for each of our own subjects, you know, the first engineering maths subject, the discrete maths subject, and all those. So by subject by subject, for our 10 subjects, the influence of the high school maths level is much the same. You find an increase as you go up. There were a few cases where the none and unknown was quite different. You know, it seemed that it was, you know, students who had that did very well. And that would be the case in the data. But that's because of the unknown part, where some of these students have come in with very good maths. And if you've got a subject with a small number of records and you've got a couple of students who've come in with good maths, it's not surprising that you'll find the coefficients in the linear model for the none or unknown were quite high. So I would like to know more about that, but I have, apart from asking students individually, without their own record, without their own history, we can't do anything about that. And for the size of the data sets we're looking at, we can't do anything about that. Okay, that's the school maths. So school maths is important. Language. Language is interesting. 43.4% of our students reported that they speak a language other than English at home, and that compares to 10% across Australia. So that's large, but that's the demographic of the sort of students Western Sydney have. We've got a large proportion of the first-year family, a large proportion of low socioeconomic status, a larger proportion from other language backgrounds. That's the university. That's one thing that the university has always been proud of doing, is looking after people like that. And language only explains about 1% of the variation in final mark. A two-sample t-test showed no evidence for a difference between English speakers and speakers of other languages, those who speak another language at home. But I think with a lot more data, which we might be able to do, I think there's a bigger story in there, because I think with some language groups, I think the data indicates that we may find they do better than English speakers, and some do worse than English speakers, and there is some evidence in the published literature that that's the case. But that's something that will need more analysis with larger data sets. So I think there's a more interesting story hidden in that one, but I can't tell you it now because it hasn't come out of that data. Now, college. Prior enrolment at Western Sydney University College ranged from 5.8% to 15.3% in each of our subjects. So that's quite a few students who have previously studied at the Foundation College before doing our first year subjects. Now, our entry standards are not high. They're actually quite low, very low in some cases. So to start at the college rather than starting at the university means that those students are probably extremely weak. Now, that's it says that college is significant. The p-value was very, very, very small. Explains 2.3% of the variation of the final mark. And the coefficient in the full model, predicting the final mark using all those predictors, it's about minus 5.5. So that says that the college students, those who come through college, can expect to do quite a bit worse than our other students. So it's an interesting one. Subject by subject, for our subjects, we found much the same thing, whether we look at discrete maths or engineering this or statistics that college students who'd been through the college certainly overall did worse. So that's our foundation college. Then international versus domestic. The percentage of international students in our subjects ranged from 3.5 to 17.0%. It's not high compared to many other universities in Australia. It explains just over 1% of the variation in the final mark using our model, with an extra 9.3 marks for international students predicted. So subject by subject, residency was significant only for one of the engineering subjects and the very large basic mathematics subject. It was only significant there. And where it was significant, it predicted higher marks for international students. Full-time versus part-time. This is the mode. Explains 1.1% of variation in the final mark using our model. And the coefficients in the models give an advantage of 4.7 marks to those who study full-time, full-time being a 3/4 or full-time or 100% load. Subject by subject, it was significant in some of the subjects, but higher marks always predicted for those students who studied full-time. Now, mode and those who failed, who sort of dropped out, FNS, really I think of as dropped out. 22% of the part-time students dropped out during this semester compared to only 12.1% of full-time students. So it's a lot more. And a chi-squared test for independence show that this difference is highly significant. Now, I don't think that's surprising. In fact, I don't think anything I've said so far has been surprising at all. Probably none of you have been surprised. This talk is not full of surprises. In fact, there's no surprises at all. Thought I'd wait till the end to tell you that rather than the beginning. Now, this data, actions, maybe we can use it and think, well, what are we going to do with it? But really, what I'm hoping to do is get Volker to get really interested in the rest of the data and do a whole lot more analysis, because I think there is some more stuff in here. We do have some different data, some attendance data and other stuff, which I think is a lot more important. And I think it will be interesting to delve into the language, but the different language groups. But for now, what we can say is maybe that previous academic background in ATAR and school maths is important. So if you are looking for places to target resources to help students to really to pick those who are maybe more likely to fail, then those with low ATAR and those with a poor maths background are probably the best places to do it, to put your resources there. The huge difference in the level of school maths shows that that's radically important. And I've always, well, every piece of research I've seen has said that, and certainly feel that with our students when you ask them what they've done, what they can do. It's really important because we build on what's done at school in our maths subjects, maybe a little less so in the statistics, but it's important. The background is important. Now, this means not just support, but also getting the message out to those who will influence our students before they come here, at high school, at primary school, with parents, with our students, so they can tell their younger siblings and younger friends that it really matters what level of maths one does at high school. That's not the message that I think is reaching most students. All students at high school seem to care about is whether they get into university, and we're told that some students are told to do a lower level of maths because it allows you more time to study for other subjects, because school will get more than sixes and look good. But the cost to the individual students is huge. They'll come, they're more likely to fail. If they fail, they start their career 1 or 2 years later. And that's, in the best case, they might spend 3 or 4 years at university and drop out, having paid lots of fees. And it's not just them. We all pay as taxpayers. All taxpayers fund our domestic students, roughly the tune of half their studies, roughly half the cost. We are paying because we're letting students who are underprepared into university. And this is a message that I keep telling everybody, but it'd be great if everybody just tries to spread the message, because our senior management certainly isn't. Universities do not have an interest in sending out this message. They want students, but I want students who can succeed. And I think Australia wants students who can succeed, who have a chance of succeeding at university. If they haven't got a chance of succeeding, they need to get prepared or do something else. Anyway, at university, maths and statistics support is really important and should be extended other than reduced, which is currently what our management is doing, much to the disappointment of many of us. And maybe programs to improve study and learning skills, and maybe there are other things people think to do to help students who are poorly prepared, who are, well, most likely not to succeed, which from this model shows from the sort of demographics that we looked at with the background. Okay, gender. It wasn't a significant predictor, but the problem is that we're just not seeing girls coming into the sort of subjects that do degrees that do maths in first year. There is still clearly a case to continue to promote maths to women, even though it's been done for many years. There needs to be more of it. Now, those students who dropped out, that's another waste of money. These students have paid a lot of fees for their subject, and for some reason they've disappeared. As taxpayers, all Australian taxpayers have paid for these students who for some reason have disappeared. So what's gone wrong? Well, in some cases there are unavoidable problems, and we all have tragedies in our lives, and students have things that that just happen. Someone gets sick or whatever. But a lot of students just, I think the majority of them are, I don't know, I think something, they either shouldn't be doing the subject, or perhaps something needs to change. If we could find students at risk of dropping out, and do something about it, intervention, support, or whatever, that would be great. If we didn't enroll those who are likely to drop out, that would be great. But what we really need to do also is find out more about that group. Okay, what's next? Other data is being collected. In fact, we've got a lot of other data, including, as I said, attendance and so on. And larger data sets might reveal more. And that's probably where I want to stop.